exercise starting with? So we're starting with a question that says express 11 choose 6 plus 11 choose 4 plus 12 choose 4 as a single binomial coefficient which looks like this. That's what they want. They want us to express it like this. So the first thing that we're going to do here is to apply the rules that we learned. And from the rules that we learned, the first rule is just that whenever you have two particular expressions, so here I'm going to say since we use the rule, this is how you write to solve. There's a rule that says n choose r plus n choose r minus 1 is the same as n plus 1, then choose r. So if the numbers on top are the same and the numbers down differ by what? Differ by 1. It's the same as you increasing the guy on top by 1, then writing or choosing the bigger one between the two expressions given below. Now you notice that 11, 6 and 4 do not qualify this statement, right? They do not qualify. So how can we make them qualify? There's another rule that says n choose r is the same as n choose n minus r. So we are able to change 11 choose 4 to be the same as, so we're going to say 11 choose 4 is the same as 11. Then 11 minus 4 gives you what? 11 minus 4, guys, is what? 7, right? So we've changed this middle part. The middle part has now become 11 choose 4. So I'll rewrite the whole question. So the whole question now can be rewritten. This is just the same as 11 choose 6 plus 11 choose 7. Then plus, this is now 12 choose 4. So you notice that these two now are going to qualify to satisfy this rule, because now the guys down differ by what? Differ by 1. So we can just now write this as 12, then we pick the bigger one, which is a what? A 7. Then this is plus 12, then choose 4. Then here again we are not able to do anything because 7 and 4 do not differ by 1. So we're going to reduce this. This is going to be 12 choose 7. This is 12 minus this, that's the same as 12 choose 8. Now this satisfies the problem to say, the formula to say if the guys on top are the same and the guys down differ by 1, just increase the one on top by 1, then pick the bigger one, the r. Because this is r minus 1, that's a 7. So your answer here is 13 choose 8. Yes, Beauty?
I'm unable.
The common mistake that people find or do whenever given such a question, they start solving. They start doing 11 factorial, they start doing 11 minus 6 factorial, then they start proceeding. No, we're not solving, we're just expressing this to get something that looks like that. And the only two rules that you're going to be using, n choose r is the same as n minus r. That's the first one, to bring something close to the neighbor. Then the second one is to combine two things. This is what we finally use at the end, which is n plus 1 choose r. Yeah, so please take note of that. The other one, so maybe for this, the next question there, the same thing, they're saying express, but now they've given us something like, so here's your expression. This is a little bit tricky and interesting. They've just said there is 13 choose 4, is it? There is 13 choose 4. Also, there's a plus. Then this is equal to, there is a 13 over 10. So here it's a fraction outside, 13 over 10. Then you're having 12, choose 9. Then there is a plus 14, choose 5. That's what you have. They want this again expressed in the form of n, choose r. That's what they want. Right? So here we're going to do the simple manipulation of just trying to bring things close to each other. So we already know that here what they've written here, this is a fraction. So rule number 1, you cannot multiply something outside with the expression 12 choose 9. So the only thing that you can do is to try to reduce this a bit. so that this is going to be 12, then this is 12 minus 9, then this is factorial, this is 9 factorial. Only this part, the other two guys, leave them the way they are. This is 13 choose 4, then the other part is 14 choose 5. So this, we just want to put, we want to introduce this guy inside. We want to make this guy enter inside here, right? This is how we do it, what we've done here. So that now at this particular point, 12 factorial times 13, it's the same as what? 13 factorial, right? Because remember, 13 factorial is going to be what? 13 by what? 12 factorial, isn't it? So this is that guy on top. At the bottom, look at what you are having. This is 10, there's a 10. Then there is 12 minus this is just 3 factorial. There's a 3 factorial there. Then there's a 9 factorial outside. This here is the same as 10 times 9 factorial. That's the same as what? 10 factorial. So it's like you're having a 3 and a 10 factorial. This is what you're going to get. So down here, I'll change this and just write, I'm having a 3 factorial and a 10 factorial. This would have only come there if you had a 13 choose what? 13 choose 10. 13 choose 10 gives you what? 13 minus 10, then 10 factorial, right? So this whole middle part has now changed. Now, how do you show it, right? How do we show it? We want to show all the necessary steps. So we're going to say we have a 13 multiplying 12 factorial. Down, you have a 10 times your what? Your 3 with a factorial, then a 9 factorial. These are just being carried down like this. We have a 13, then there's a 4 plus. Then here, we're just having a 13, then choose 4. This is plus 13 factorial. Then here, we're having a 3 factorial and a 10 times a 9 factorial. I'm just trying to show you, to show you how you can be presenting your work. This here will just be 13 factorial. This is 3 factorial and a 9 and a 10 factorial. 10 factorial, then plus, this is 14, choose 5. So like I said, we're not solving, we're just putting it in the form of n choose r. This will be 13 factorial. This is the same as 13 choose what? 13 choose 3. Or 13 choose what? Is it? Either way, it's up to you, right? It can either be, you can think about it as 13 choose 3, because it's the same as 13 choose 10. Remember that rule that says n choose r is the same as n minus r at a. So now why am I deciding to use 13 choose 3? Because I'm thinking this guy has to be close to that. I cannot go and use 13 choose 10. I would have to change and bring it back to this. Yeah, so I need something that's close so that it will be easy to change. Yeah, so this is going to be the same as the numbers on top are the same. The ones down differ by 1. So this is going to be 14. Take the big one, which is a 4. Then you're having 14 choose 5. This is going to be 15. Take the big one, which is 5. So this is the final answer. We have expressed it in the form of n choose r as a single binomial coefficient. This is just a number, so now we're calling it a coefficient. So that's how you handle such questions, guys, whenever they ask. Question 10, this one here, right?
Yeah.
So question 10, they're saying by substituting 0.08 for x in 1 plus x to the power half and its expansion, find root 3 correct to 4 significant figures. That's what they want. Yeah, so we let x be equal to this in the expression 1 plus x to the power half. Then we find the square root of 3. That's what they want us to do. So we'll do the replacement. This is 1 plus 0.08. This is a half. Then we know the expansion to this, right? We know the expansion of 1 plus x to the power half. If we expand it, this is going to give us 1 plus what? Plus half x plus half. This is 1, this. Then there's what? A 2 there. Then there's x squared. And so on and so forth. So I'll just end here. This is, we're now replacing, right? We are saying 1 plus 0.08 to the power half. So wherever there's x here, they want us to replace with 0.08. So it's 1, there's half, 0.08. Then plus, this is just half, negative half, then you have 2, then this is 0.08 squared. That's the first thing that you do after expanding, just replace. Then here, this part now is where we need to do a little bit of some manipulation. So we are given that this is going to become 1.08 when you add them, right? 1 plus 0.08. So this, you can just drag this guy along. This is going to be 0.04 when you multiply that. Then this is going to be negative 1 over 4. 0.08 squared over 2. Then here you are having, you can change this into a fraction. This is the same as 108 over 100 to the power what, half, right? It's the same as 1.08. We have not changed anything because you know to say this is the same as having a 1 here. You multiply this by 100, multiply the down part by 100. That's where the 108 over 100 is coming from. Is everyone okay, guys, up to this point? Is there anyone who has any question here? Anyone who is lost? John, is this okay?
Yes, sir. Yes, sir. Understood.
Numezi, this is okay, right? Okay, so the next thing here, so I'll keep this guy coming along. So I'll just represent this part by K so that I don't waste time rewriting it again and again. So this whole part, I'm calling it to be K, because I'll bring it at the end. I just want to lessen the time I spend rewriting it. So the half here is representing a square root. So this is the same as the square root of 108 over 100 is equal to what? K. So I'm going to split the square root, separate it, I mean. This is going to be like this. This is equal to K. And this is going to be, this part here is going to give us the same as what? 36 by 3. Then down, you know, it's a 10. This is equal to K. That's what you have. Then this is going to be a 6 root 3. Then we're having a 10 is equal to K. I can reduce this to be root 3, then root 5. This is equal to a K. So hope everyone is okay on this part here. This is, they want root 3. They want the square root of 3, right? So that's the reason why I went straight ahead and divided 3 into 108. So this into there, that's a 3, then into 18, that's a 6. That's where the 36 came from. So this is the 36 by 3. Yeah, so we're manipulating it like this. At this point, we're just looking forward to make root 3 to be the subject of the formula. So we're going to cross multiply and say 3 root 3 is the same as 5K. We divide this side by 3, divide this side by 3. So meaning we have an expression for root 3 now. Root 3 is approximately 5 over 3 multiplying K. Remember what K was? K was 0.04 plus negative 1 over 4, 0.08 to the power 2. This is over 2. Remember this? That's the K, right? That's K. So now we're saying root 3 is exactly equal to this whole thing by the time you're done solving it. Now we don't have a calculator. How do you go about it? We just break it down the usual way. Yeah, so we're going to avoid to use fractions so that things do not become complex because you want to save on time. This is going to be, sorry, I paused this. Okay, the guys who are going to watch the video are going to, okay, yeah. So this is 0.08 times 0.08. So 8 times 8, that's a 64. Then we're having 4 decimal places. So we have to go back 4 times. So this is going to be 0.00664. Then there is a 2 down in the denominator, right? There's a 2 down. So instead of writing the 2 down, I just say 0.5 because it's half, right? So that's what we're going to have. Okay, so just a minute, guys, for the sake of those who are going to watch the video. I won't say anything, but I hope they'll just be able to follow from where the video had stopped recording. So I just used this whole expression. I called it K in case you'll be wondering where the K is coming from. Then we brought it back here. Okay. So now we are simply going to multiply everything. This is 1.67. You have 1.04. Here we solve everything here. So ignore the decimal point, just focus on the numbers, right? We're just going to multiply 25 by what? By 5. So we're having 25 by 5. Then this answer we're going to get, we multiply it by 64. How many decimal places? 1, 2, 3, 4, 5, 6, 7, right? So when you multiply this, everything here, you know to say 25 by 5, that's a 125. 125 by 64, so we're just going to say 125 by 64. We're training ourselves to work without a calculator. So we know 125 plus 125 is it's what, 250, right? When you add 2 of these, right, it's 250. Now you have 4 of them, that's going to be 500. Then if you have 6 of them, that's going to give you what? We're saying 125 plus 125 gives you what? Gives you a 250, right? So it's like you have another 250 and another 250 to make them 6, right? So this is going to be 750. So this will be 750. This will be 0, 0. This is 0. That's 8,000. Then we bring back our how many decimal places? 6. Is it 7? So 1, 2, 3, 4, 5, 6, 7. So I have 0.0008. This is what we're having. So we're just approximating 1.67. 1.04 minus this, we write it the long way. You show all your working. Put your point there. There are 3 zeros with your 8. Put zeros here as well. Yeah, so put zeros there. This is 3. This is 9. Carry 1 there. That's a 2. That's a 9. That's a 3. 0.1. So here I'm having 1.0392. It's just an approximation, guys. So this times this. Again, ignore the decimal points. We know it's 4 here and 2 there, so it will be 6. Multiply 10392 by 167. Yeah, so if you multiply this if we just go throughout, I'll just go straight here to use the calculator on my phone, which you can do this guy manually. So 10392 multiply 167. I'm getting a 1735464. So now there are 6 decimal places. So 1, 2, 3, 4, 5, 6. So you found the square root, the approximate square root of root 3, of square root of 3, which is 1.74, I think, if you punch on the calculator. So this is just an approximation, but it's still correct. Is this okay, Madam Beauty?
Yes.
So you see that it's very long, right? So this is how you are supposed to do this. It takes so much time, and if you ever see this in an assessment, please try to do this as the last thing after you're done with everything else, because this to same multiplication will really waste your time. Yeah, so you can't waste so much time for what, 4 marks or 3 marks. Yeah, so this is what you have. Okay, so on the same document, it's the same thing that you do here. This is actually a similar thing with your with your tutorial sheet question. So these questions, people hate them, and they are always going to be given mostly. Yeah, at least you guys have a variety. There's tutorial sheet 4 and tutorial sheet 5, so at least they have a variety from where the questions can come from, but the possibility of having interesting things or tricky things is actually there. So this is the same as this, -half. This here is the same as 1 minus what? You always equate what you have to 1 plus x is equal to 0.99. So this will be 1 minus 0.99 is equal to x. So if you subtract, this should be 0.1, I think, 0.01 if I'm not mistaken. 1.00, 0.99. This is a 0, this is a 1, that's a 9. This is going, this is a 10 here, that's going to be a 1. This is a 9, that's going to be 0. Yeah, so x has to be this. Yeah, so 1 minus, it's a negative actually, because it's the x, it's a 1 that goes on the other side, right? If we are solving for x here, we're saying x is equal to 0.99, then minus 1. So the answer is supposed to be negative 0.01. So here, we're supposed to put x then to the power negative what? Negative half. Then we know to say wherever there's x, by the time we're done solving, wherever there's x, you have to put negative 0.01. Yeah, so if you put a negative here already, meaning there won't be need for you to put a negative because the negative has been accounted for here. Yeah, but if you take this as positive, meaning what number of x should you add here for 1 to act on that number to give us 0. That meaning you put a what? A negative, that, right? Yeah, so it's up to you how you do it. Whether you already put you put the negative here in advance as you expand your expression, your negative half of x, then do your expansion, then do the replacement in the expansion you're going to do. Always be ending on the third term at least. It increases your accuracy and your precision. Yeah, so hope this makes a little bit of some sense. Any questions on this tutorial sheet for last year? This was a little bit more challenging than yours. Any questions here?
Yes, question 3.
Question 3. This one here, the one that says show. Is it the one that you're asking, Solomon? This one here?
Yes, sir.
Okay, so whenever they say show, they already know that the left is equal to the right, or the statement given is an identity. They already know that it's equivalent. So when they say show, you're just proving or confirming whatsoever has been given. Yeah, so this is a proof that tells us that all the binomial coefficients are actually gotten from this same expression that you have, and this was it was a 0 here. So these are all just the binomial coefficients. We're saying provided you do this, and the last thing is n choose n, the answer is always the same as 2 to the power n. This is true provided the n value you're using is what? Is positive. So you give yourself any number that you want, right? So we'll choose n to be, let's say 3 or 4. It's up to you. So I will just choose 4. So if I pick 4, meaning I'm going to have 4 choose 0. We're saying 4 choose 0 plus 4 choose 1 plus 4 choose 2, then plus 4 choose 3 until you reach 4 choose 4. And until n, right? That's the condition. They're saying it's the same as you raising 2 to the power the n that you chose. So the left should be equal to the right. The left in this case, the left hand side is this part. That's the left. If you go on the Pascal's triangle, on the fourth staircase, these are the coefficients. 4 choose 0 is simply 1. 4 choose 1 is simply 4. 4 choose 2 is simply 6. 4 choose this is simply 4. Then 4 choose 4 is just the same as 1. When you add this is what? This gives you a what? This gives you a 10. A 10. This gives you a 16 by the time you're done solving, right? This is your left. Your right hand side is 2 to the power 4. This is also what? 16. Hence, the left hand side is equivalent to the right hand side, hence shown. This is how you handle anything that says show. Is this okay?
Yes, sir. Yes, it is.
Yeah, so this is basically what you have. Any other questions? Be puzzled. Say, how do we go about this? It's the same exact thing. The only difference is that they have brought one of the guys on the other side. So this has to be. So they just took. If you know how to prove this, right? Break down this. The normal, break down this. Take this guy, whatever you've broken down for this, and take it on the other side. It will carry minus, right? Whatever you did to this, do it this side but with a negative in front. Then you confirm that what you get this side will be the same as K choose R. So that's how they can just manipulate this. We are proving, whenever they say prove, meaning you work with the letters. When they say show, you pick any number to represent the letter that I've used. When they say show, you pick a number. Then when they say prove, you stick with the letters that they've given you until you show that the left is equal to the right. Yeah, so this is, basically what you have. So hope this shows you that you should actually be careful with binomial, because it's going to be very, very tricky and hard. Yeah, I must promise you that the sheet 4 questions will be friendly, but binomial, they do try to make it as crazy as possible, and you actually get to feel as if you didn't understand the topic. Look at this guy here. Now you start questioning what you know. By writing y to be equal to x plus this, find the first 4 terms in the expansion of this. So they just want you to write this as 1 plus y to the power 6. Expand this, but only give them the first 4 terms. Don't go more than the 4 terms. So what are the coefficients when, so this is the expression here, what are the coefficients when the staircase is when n is equal to 6, right? Remember, we have this staircase number 2. You can have this. You can have 4, 6, 4, 1. You can have 1, 5. You can have 10, 10. This is a 5 and 1. Or number 6, you have 1, 6. This is 15. This is 20. This is 15. This is 6. This is a 1. So these are the coefficients. They don't want all of them. They just want you to get what? The first 4 terms, which is using these four expressions there. So we're going to say 1, 6, 15, and 20. The first term is simply 1, so it's just going to be 1. The second term is y, right? This is y squared. This is y to the power 3. Now they gave us y to be what? Y is equal to x plus x squared. So wherever there's y, replace back your x plus x squared. That's what they want. 15, do x plus x squared again, plus 20. This is x plus x squared cubed. So you have a lot of things to do here, because now you have to expand every single term. Plus, this is 15. You have to expand this first, because this is raised to the power 2, right? This is x squared plus this is 2x to the power 3 plus x to the power 4. When this guy multiplies itself twice, the 15 is waiting outside. Again, you do the same. This has to multiply itself 3 times. So it's like you're doing a Pascal's triangle within a Pascal's triangle. So the expansion will be very long. So you expand this part. Then here you just add the necessary terms that are needed. X to the power 2, then to be 15x squared plus a 30x to the power 3 plus a 15x to the power 4 plus a 20, and the expression you get this side. Gather the like terms here. You have 1 x. There's only one thing that has x here. The rest have x squared. So this will be plus a 21 x squared, then plus a 30 x to the power 3 plus a 15x to the power 4, and so on. So this is what you basically get. So don't overthink things. The principles you've learned are still going to be valid, just in a very unique way. Just follow the question. Let the question remind you of the principles that you need to apply. So yeah, this is how you handle any question that has to do with such. Yeah, so you don't have to worry about expressions that look like this, because these will come after learning partial fractions. Yeah, so only these that you learned, right? And be careful to remember that you always have to make the first term to be 1, right? So here you have to factorize 4. It will be 4 to the power negative 1. It will be 1 plus x over 4 to the power negative 1. Here again, you switch these things that are inside. 1 plus x is the same as x plus 1. We always want the first term to be 1, so this is going to be 1 plus x, then to the power negative what? Negative half. Put it in a way that you're comfortable with, respecting the formulas and the theorems that you did. And this is just the task for today, question 7 and question 8. You can sleep on these. At least they will challenge the knowledge that you have on binomial.